In this video, we're going to use the calculator specifically to create a frequency and then list, and then from there create a relative frequency list. It may be easier in an example like this to actually do the problem by hand because the list is short and it's already in order. So I can quickly count the number of data within each class. However, if you really wanted to do this on the calculator, maybe in the future the list is not ordered or it's a little bit longer, you might want to pick up the calculator. For much longer lists, you definitely want to use something like StatCrunch or Microsoft Excel, which you do have access to through your WCC email account. So anyway, I'm going to pull up the calculator. The first thing I did was I went to Stat, Edit. I've already typed in the data in the list. That's probably the longest part of this process. The next thing I'm going to do is actually go straight for the histogram. Now, the way the text presents drawing histograms, we really create the frequency list first, or the frequency table first. But in the calculator, there is no quick way or easy way just to only do a frequency list. So what we're going to do is come to second y equals. I'll press enter to get into plot 1. I'm going to turn it on and I'm going to select the histogram. You can see that my data are in list 1. I'm using a frequency of 1 right now. In other words, each piece of data is only counting once within that list. And then a quick zoom for most statistical graphs is zoom and then select number 9 for zoom stat. But as I press trace, notice that the bins are all kind of strange values here. We've got a minimum on this bin of 30,115. In the problem statement, if I go back to that, it says to use a lower class limit of 30,000 and a class width of 6,000. And really that's all I need to know in order to change my bins so that it matches what the problem was asking for that frequency table. To do that, I need to go to the window. So your X-min is the same thing as your lower class limit. So I want to set those values to be the same, and that's going to be 30,000. Now I could change the X-max. Sometimes you might need to, but if you're not sure yet what to change it to, just leave it alone. This is really how you would probably do it in practice. You might come back to it later. So I'm going to move on down to X scale. The X scale is the same thing as the bin width. So I'm going to set that at 6,000. I have done this problem already, so I do know that my Y max needs to be just a little bit higher. Again, if I did not know that and I just press graph, I see that this first bin is a little too high. When I press trace, I see that it goes up to 14. So I would come back to the window and I would select my Y max to be something more than 14, for instance 15. And then pressing graph, at least now I can see each bin clearly on the screen. So this first bin goes from 30,000 just less than 36,000, and it has a frequency of 14. So when I come back to the problem, I'm going to type 30,000 for the lower class limit, but just below 36,000 would be 35,999 since I'm dealing with discrete data. Another way to think of that is the distance between lower class limits should be 6,000. So this next bin, if I go back to my calculator and I scroll over, notice that the next bin begins right at 36,000. But going back to that first bin, it has a height of 14, or in other words, that class has a frequency of 14. And I could keep going like this. The next bin was up to 42,000. So you could think of that as just below 42,000 with a height of 10. The next bin, notice, has nothing, so it's going to have a frequency of 0, and then the last bin will have a frequency of 1. So again, this is kind of going around to get to the final answer, and I've already submitted that one here so that you can see how that looks. Now, when it comes to the relative frequencies, this you might just go back to your traditional calculator. So notice that the classes are the same. They need to stay the same. So you just really are repeating what you did earlier. Also notice that there are 25 total pieces of data. Okay, that's our total count. So if I come back to my calculator, if I want to get the relative frequency for that first bin or class, I will take the number of data within that first class and divide by the total number of data, and that's where I get my relative frequency from. And I did that for each of these here. Again, if you're curious about how to get to Excel, and you go to the Wilson Community College website, up here at the top where it says Office 365 email, there will be a place for you to sign in with your email. And then if you do not see the options over here on the side for Excel, then come up here to the 9 dots at the top, and you should definitely see the option for Excel within that app.